Problems involving complex summation technique I. So we have been doing a lot of problems involving such techniques, and this is the third video, and I hope you have watched all the previous videos before coming to this so that it will be easier for you to understand how to solve. As usual, we will first assign to the imaginary part of it to the pi theta, and then use some properties such as linearity and product with real numbers to take it outside the sum and then solve it. Yeah, let's go ahead. Sum from n equals to 0 to infinity 1 by 2 to the power n, and now this is just imaginary part of e to the power I n pi by 3. Yes, now take the imaginary part outside. Imaginary part of the sum from n equals to 0 to infinity of e to the power I n pi by 3 by 2 to the power n. Yes, now this is just the metric series and its common ratio is also less than 1. So we can use the infinite GP formula. Sum from n equals to 0 to infinity e to the power I pi by 3 by 2 to the power n. Yes, now good. Now use the infinite geometry series formula, which is just a by 1 minus r. The a is first term is just 1 by 1 minus r is e to the power I pi by 3, yes, by 2. Yes, now this is the ratio. Now we just need to find its imaginary part. Imaginary part is now of 2 by 2 minus e to the power I pi by 3. Yes, now there are two ways. One of the ways is just expand this as cosine sign in the rationalized denominator. The other is to multiply by the same denominator with a conjugate over here. So basically by 2 minus e to the power minus I pi by 3 by 2 minus e to the power minus I pi by 3. Yes, okay, and now we get imaginary part of 4 minus 2 e to the power minus I pi by 3 by, now this is just 4 minus 2 of e to the power minus I pi by 3 plus e to the power I pi by 3, and then this is just plus 1. Yes, and now we have imaginary part of 4 minus 2 times e to the power minus I pi by 3 by 5 minus, this is 4 cos pi by 3. Yes, now let's try to find its imaginary part. So this is just real number, so that it's ignored because that's just real number. And next thing is, okay, so next thing will then be just this expression over here. This expression over here will just matter, and we know that the imaginary part will be minus 2 sine of minus pi by 3 by 5 minus 4 cos pi by 3. This will be our answer. Now let's find it. Now the sign comes out and minus minus cancels out, so we have 2 times sine of 60 is root 3 by 2 by 5 minus 4 into cos of 60 is 1 by 2. Yes, so we just have, this is just root 3 minus, this is 5 minus 2. Yes, and that is root 3 by 3, that is 1 by root 3. What a neat answer, what a proper answer. Can't really believe. Over here the original thing was some signs and some just exponential, like decaying function, yeah, but the answer, overall answer up to infinity, sum up to infinity, was just 1 by root 3. What a amazing thing to look at. and the solution development also, it was just a clever use of the exponential function, and it was really good solution. Hope you also enjoyed it. Thanks for watching, and look forward to seeing you in the upcoming videos too.